All right, today we're going to talk about multiplying radicals. All right, so we can multiply radicals if they have the same index. Now, I'm only going to be working with square roots, so I'm not going to worry as much about that. We multiply what's outside the radical first. So the coefficients, then we're going to multiply the numbers that are under the radicals together. And then we simplify. Okay? So, looking at this first example, I have no coefficients, okay? But, so I'm going to go ahead and I'm going to multiply 3 times 3. I'm going to multiply with my radicands. And 3 times 3 is 9. Now, 9 is a perfect square, and the square root of 9 is 3. Okay. All right, so let's look at another one. I've got 2 square root of 12 times 4 square root of 15. So I'm going to take and I'm going to multiply 2 times 4 and then take the square root of 12 times 15. All right, 2 times 4 is 8. And 12 times 15 is 180. All right, so now we're going to simplify 180. And I'm going to think through that. What can divide nicely out of 180? So, remember our list, we had this 4, our perfect squares are 4, 9, 16, 25, 36, 49, 64, 81, 100, and we have a few others, but we're going to stick with these. Okay. Well, I know 100 is not going to. 81 doesn't. 64 doesn't. 49 doesn't. 36 might, so let's try that one. So I'm going to take 180 divided by 36, and I get 5. So 36 and 5. Well, I know 36 is a perfect square. It's 6 times 6. So I end up with 6 square root of 5 there. So I'm going to get 8 times 6 square root of 5, because 180 simplifies to 6 square roots of 5. 8 times 6 is 48. So I get 48 square root of 5. All right, we're going to do one more. Of these, and then I have one other that I want to show you. All right, so I'm going to take and I'm going to multiply my coefficients together. So on that second radical, I have a coefficient of 1. Okay, so I'm going to take 2 times 1, and I'm going to multiply what's under the radical together. Well, 2x to the third times 3x. Well, 2 times 1 is just 2. And 2x to the third times 3x is 6x to the fourth. All right, so let's go ahead and simplify 6x to the fourth. Or the square root of 6x to the fourth, I should say. I'm going to split that up into its two parts. the 6, and the x to the 4th. Now 6, the only things that divide out of 6 nicely are 3 and 2. So I have no perfect squares there. Okay? So that's as simplified as we're going to get. We're going to leave it like that. However, I know that x to the 4th, all right, the square root of x to the 4th. It's even, so I know it's a perfect square as far as with working with variables go. So I'm going to take the exponent 4 and divide by 2. And that gives me what I'm pulling out. Okay, so I get x squared. So I'm going to get 2x squared square root of 6. All right, and our final one. So looking at this, there's one thing that pops to my mind that we could probably most likely do with this and would be true. Okay, anytime we've had parentheses like this, we could use the distributive property, and it works here as well. So I'm going to take the square root of 3 times 3, which just gives me 3 square root of 3, and then the square root of 3 times the square root of 6. Okay, so those are multiplying, so I'm going to go ahead and multiply them together, which gives me 18. Now we're going to simplify 18, or the square root of 18, I should say. And I know 9 and 2 give me 18. Well, 9 is a perfect square, right? We're looking for that perfect square because a square root undoes a square. So square root of 9 is 3. So I get to pull out a 3 from that. So I end up with 3 square root of 3 plus 3, and the only thing left under my radical is 2. Since those are adding, I can't combine them, and that's how it worked.